Welcome, everyone. Today we're going to take a deep journey into one of the greatest adventures in human history, the exploration of the moon, a story filled with ambition, rivalry, courage, science, mystery, and dreams of the future. Our story begins in the middle of the 20th century, during a tense period known as the Cold War, when two superpowers, the United States and the Soviet Union, were competing not only on Earth but beyond it. This competition, known as the space race, pushed technology forward at an incredible pace. In 1957, the Soviet Union shocked the world by launching Sputnik, the first artificial satellite, into orbit around Earth. That small metal sphere marked the beginning of humanity's journey into space. Just 2 years later, in 1959, the Soviet spacecraft Luna 2 became the first human-made object to reach the moon, crashing into its surface and proving that the journey was possible. Soon after, Luna 9 achieved the first soft landing on the moon, sending back the first photographs from its surface. These early robotic missions showed that the moon was not just a distant light in the sky, but a real place that machines could reach. The United States responded with its own ambitious lunar program, determined not to fall behind. President John F. Kennedy boldly announced that America would land a man on the moon and return him safely to Earth before the decade was out. At the time, this goal seemed almost impossible. Computers were less powerful than today's smartphones. Rockets were still experimental, and no human had traveled that far from Earth. Yet the challenge inspired thousands of engineers, scientists, technicians, and astronauts to work together toward a single objective. The Apollo program was born, a massive effort involving hundreds of thousands of people. After years of testing, failures, and tragedies, including the heartbreaking Apollo 1 fire that claimed the lives of 3 astronauts during a ground test, NASA continued pushing forward. Each mission brought new lessons, orbiting Earth, testing equipment, and finally orbiting the moon. Then came Apollo 11 in July 1969. The world watched as a giant Saturn V rocket lifted off from Florida, carrying astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins toward history. After traveling nearly 384,000 kilometers through space, the spacecraft entered lunar orbit. Armstrong and Aldrin transferred into a small lunar module named Eagle, leaving Collins behind in the command module orbiting above. As Eagle descended toward the moon's surface, alarms sounded in the cockpit, and fuel levels dropped dangerously low. Armstrong manually guided the spacecraft away from a rocky area and found a safer landing spot. With only seconds of fuel remaining, he announced the famous words, "The Eagle has landed." On July 20th, 1969, Neil Armstrong stepped down the ladder and placed his boot onto the dusty lunar surface, saying, "That's one small step for man, one giant leap for mankind." In that moment, humans became a multi-world species, even if only briefly. Walking on the moon was unlike walking on Earth. The moon's gravity is about 1/6 of Earth's, so astronauts moved in slow, bouncing motions. Their bulky spacesuits were like personal spacecraft, providing oxygen, controlling temperature, and protecting them from radiation and tiny meteoroids. The surface beneath their feet was covered in fine gray dust called regolith, formed over billions of years by meteor impacts. Armstrong and Aldrin collected rock samples, planted the American flag, conducted experiments, and spoke with President Nixon by radio, while millions of people listened on Earth. After about 2.5 hours outside, they returned to the lunar module, blasted off from the moon, rejoined Collins in orbit, and safely returned home, splashing down in the Pacific Ocean. The success of Apollo 11 was followed by several more Apollo missions. Astronauts drove electric lunar rovers across the surface, explored craters and mountains, and brought back hundreds of kilograms of lunar rocks. These samples revealed that the moon likely formed billions of years ago after a massive collision between early Earth and a Mars-sized object. The rocks also showed that the moon once had volcanic activity and that its surface has been shaped by countless impacts. However, despite these incredible discoveries, human missions to the moon did not continue forever. The last crewed mission, Apollo 17, took place in 1972. After that, humans stopped going to the moon. There were several reasons. The Apollo program was extremely expensive, costing billions of dollars. Once the United States had achieved the goal of landing on the moon before the Soviet Union, political urgency faded. Public interest began to decline as the missions became less novel. Governments shifted focus toward other priorities, including space stations in Earth orbit and the development of the space shuttle. For decades, no human traveled beyond low Earth orbit. Yet the moon was not forgotten. Robotic missions from various countries continued to study it. Orbiters mapped its surface in high detail, searching for valuable resources and studying its geology. Scientists discovered evidence of water ice hidden in permanently shadowed craters near the lunar poles. This finding changed everything because water could be used not only for drinking but also split into hydrogen and oxygen to make rocket fuel. Suddenly, the moon was not just a destination for flags and footprints, but a potential stepping stone for deeper space exploration. In recent years, a new era of lunar exploration has begun. Countries like China and India have successfully sent spacecraft to orbit and land on the moon, demonstrating advanced technological capabilities. Private companies have also entered the scene, developing rockets and landers with the goal of making space travel more affordable. NASA has launched the Artemis program, named after the twin sister of Apollo in Greek mythology, with the goal of returning humans to the lunar surface. This time, the plan is not just to visit briefly, but to build a sustainable presence, including a space station in lunar orbit called Gateway and eventually a base camp on the surface. The Artemis missions aim to land the first woman and the first person of color on the moon, marking a new chapter in human exploration. As we look back at the history of moon exploration, we see a story driven by competition, courage, tragedy, innovation, and hope. From the early robotic probes that crashed into the lunar surface to the historic footprints of Apollo astronauts, each step has expanded our understanding of the universe and our place within it. And now, as technology advances and new generations dream of space, humanity stands once again on the edge of returning to our nearest celestial neighbor, not just to visit, but to stay. Now let us look more closely at what it truly meant to travel to the moon during the Apollo era, and why the Apollo 11 mission remains one of the most carefully planned and daring operations ever attempted by humanity. When Apollo 11 launched in July 1969, it was not simply 3 astronauts sitting on top of a rocket. It was the result of years of engineering breakthroughs, thousands of tests, and lessons learned from earlier missions. The Saturn V rocket that carried the crew was the most powerful rocket ever successfully flown at that time, standing taller than a 30-story building and generating millions of pounds of thrust at liftoff. Inside the spacecraft were 3 main sections: the command module where the astronauts lived during most of the journey, the service module that provided power and propulsion, and a lunar module that would actually land on the moon. After reaching Earth orbit, the rocket's upper stage fired again to send the spacecraft toward the moon in a maneuver called translunar injection. For 3 days, the astronauts traveled through deep space, performing course corrections and checking systems while Earth slowly shrank behind them and the moon grew larger ahead. When they entered lunar orbit, the spacecraft had to fire its engine at exactly the right moment to be captured by the moon's gravity. Any mistake could have sent them drifting into space or crashing onto the surface. Neil Armstrong and Buzz Aldrin then climbed into the lunar module Eagle, separating from Michael Collins, who remained in orbit inside the command module. Collins had the lonely but critical task of circling the moon alone, knowing that if something went wrong during the landing, he might have to return to Earth without his crewmates. As Eagle descended, its computer began flashing unexpected alarms due to data overload. Yet Mission Control in Houston quickly determined it was safe to continue. Armstrong looked out the window and saw that the automatic landing system was guiding them toward a rocky field filled with boulders. Taking manual control, he carefully piloted the craft forward, searching for a clear spot. Fuel levels dropped to less than 30 seconds remaining before he finally touched down. That landing demonstrated not just technological power, but human skill under extreme pressure. Once safely on the surface, the astronauts prepared for their moonwalk. It took hours to depressurize the cabin, check their life support systems, and climb down the ladder. When Armstrong placed his foot on the moon, the image was broadcast live to hundreds of millions of viewers around the world. The moment united people across nations, cultures, and political divisions. During their time outside, Armstrong and Aldrin set up scientific instruments, including a seismometer to detect moonquakes and a laser reflector that scientists still use today to measure the exact distance between Earth and the moon. They collected soil and rock samples that would later reveal the moon's violent history of impacts and volcanic activity. Moving in low gravity required practice. At first, astronauts tried walking normally, but they soon discovered that a hopping motion was more efficient. Every movement had to be deliberate because falling could damage their suits. The lunar surface was silent and airless, with a black sky even during daylight because there is no atmosphere to scatter sunlight. Temperatures swung dramatically between extreme heat and extreme cold. Despite these harsh conditions, the astronauts described the experience as both beautiful and surreal. After completing their tasks, they re-entered the lunar module, rested briefly, and then ignited the ascent engine to lift off from the moon. The lower half of the lander remained behind, while the upper half carried them back into orbit. Docking with the command module required precise maneuvering. Once reunited with Collins, the crew began the journey home. Re-entering Earth's atmosphere was another dangerous phase, as the spacecraft had to withstand intense heat while slowing from thousands of kilometers per hour. Finally, the capsule parachuted safely into the Pacific Ocean, where recovery teams awaited. The success of Apollo 11 proved that humans could travel to another world and return safely. But Apollo missions continued after that, bringing even greater scientific returns. Later crews stayed longer on the surface and used lunar rovers to travel several kilometers away from their landing sites. These battery-powered vehicles allowed astronauts to explore mountains, valleys, and craters in greater detail. With each mission, knowledge grew. Scientists confirmed that the moon likely formed about 4.5 billion years ago, probably after a massive collision between early Earth and a Mars-sized body. The debris from that impact eventually gathered together to form a moon. The samples brought back during Apollo missions continue to be studied even today, revealing new insights as technology improves. Despite these achievements, by the early 1970s, public excitement had begun to fade. Space missions were becoming routine in the eyes of many viewers. The cost of maintaining such ambitious programs was enormous, and governments faced other priorities, including economic challenges and geopolitical tensions. After Apollo 17 in 1972, which included the first scientist astronaut to walk on the moon, no further crewed lunar missions were launched. Instead, attention turned to building space stations in low Earth orbit and developing reusable spacecraft. The dream of returning to the moon seemed distant. Yet robotic exploration never stopped. Orbiters mapped the lunar surface in high resolution, identifying mineral compositions and searching for water. Discoveries of ice deposits near the poles sparked renewed interest because water could support future human presence. Meanwhile, new space agencies emerged on the global stage, demonstrating that lunar exploration was no longer limited to two superpowers. The story of Apollo 11 is not only about planting a flag, but about expanding the limits of what humanity believed was possible. It showed that with determination, collaboration, and courage, seemingly impossible goals can be achieved. After the Apollo era ended, many people believed the moon would remain untouched by humans for generations, yet exploration did not truly stop. It simply changed form. Instead of astronauts, robotic spacecraft became the main explorers, orbiting, landing, and studying the lunar surface with increasingly advanced instruments. Over time, more nations joined the effort, transforming lunar exploration from a two-country rivalry into a global scientific endeavor. One of the most important developments in the 21st century came from India. In 2023, The Indian Space Research Organization successfully carried out the Chandrayaan-3 mission, achieving a soft landing near the Moon's south polar region. This was a remarkable accomplishment because the South Pole is one of the most challenging areas to reach due to its rough terrain and deep shadows. Chandrayaan-3 made India the fourth nation to achieve a successful soft landing on the Moon. The Vikram lander touched down carefully, and the Pragyan rover rolled onto the surface to conduct experiments. The rover analyzed the chemical composition of lunar soil and searched for evidence of water ice. The success of this mission demonstrated how emerging space powers are now playing leading roles in deep space exploration. Around the same time, China made history with its Chang'e 4 mission, launched by the China National Space Administration. In 2019, Chang'e 4 became the first spacecraft to land on the far side of the Moon, the hemisphere that always faces away from Earth. Because direct communication with Earth is impossible from that side, China first placed a relay satellite in lunar orbit to transmit signals. The lander and its Yutu-2 rover explored the far side's terrain, studying soil composition and conducting scientific experiments. This mission proved that complex operations on the far side were achievable and opened new scientific opportunities, since that region is shielded from radio interference from Earth and offers unique conditions for astronomical observations. These modern missions revealed something extremely important. The Moon contains resources that could support future human activity. Scientists confirmed the presence of water ice trapped in permanently shadowed craters near the poles. Water is essential not only for drinking and growing food, but also for producing oxygen and hydrogen fuel. If future explorers can extract and use these resources, the Moon could become a refueling station for missions to Mars and beyond. This idea has reshaped long-term space strategy. Instead of brief visits, space agencies are now planning sustainable exploration. This brings us to NASA's Artemis program, named after the twin sister of Apollo in mythology. Artemis represents a new phase of lunar exploration. Unlike Apollo, which focused on winning a race, Artemis focuses on building lasting infrastructure. The program aims to land the first woman and the first person of color on the Moon, reflecting a broader and more inclusive vision of space exploration. The first mission, Artemis I, successfully tested the powerful Space Launch System rocket and the Orion spacecraft in an uncrewed flight around the Moon. Future Artemis missions will carry astronauts, establish a small space station in lunar orbit called Gateway, and eventually create a base camp on the surface. The goal is not just to visit for a few days, but to stay for weeks or months at a time. Engineers are studying how to build habitats using lunar soil, possibly through advanced 3D printing techniques. They are designing new generation spacesuits that allow greater flexibility and mobility. They are also developing systems to generate power through solar arrays placed in areas that receive near constant sunlight. The idea of a permanent moon base no longer belongs only to science fiction. While true colonies with large populations are still decades away, serious research is underway. Living on the Moon presents enormous challenges. There is no breathable atmosphere, radiation levels are high, and temperatures can swing from extreme heat to extreme cold. Dust particles are sharp and cling to surfaces, potentially damaging equipment. Any long-term base would require reliable life support systems, recycling of water and air, protection from radiation, and stable energy sources. Despite these difficulties, many experts believe that establishing a human presence on the Moon is a necessary step toward deeper exploration of the solar system. The Moon can serve as a testing ground for technologies that will later be used on Mars. In addition to crewed missions, robotic rovers continue to play a crucial role. Moon rovers are specially designed vehicles built to operate in low gravity and harsh conditions. Early rovers used during the final Apollo missions were driven by astronauts and allowed them to travel several kilometers from their landing sites. Modern robotic rovers are either remotely controlled from Earth or operate semi-autonomously using onboard software. They carry cameras, drills, spectrometers, and other instruments to analyze rocks and soil. Solar panels typically provide power, while onboard batteries store energy for operations during the lunar night. These machines can survive conditions that would be dangerous for humans and can explore areas that are difficult to reach. As lunar exploration advances, public interest has also revived, but alongside excitement, some old doubts have resurfaced. Moon landing conspiracy theories claim that the Apollo missions were staged. However, overwhelming evidence supports the reality of the landings. Independent tracking stations around the world monitored the missions in real time. Thousands of engineers and scientists worked on the program, making a coordinated hoax nearly impossible. Retroreflectors placed on the moon by Apollo astronauts are still used today by scientists who bounce lasers off them to measure the Earth-Moon distance with extreme precision. High-resolution images from modern lunar orbiters clearly show the descent stages of lunar modules and the tracks left by astronauts and rovers. The scientific community worldwide has analyzed lunar samples for decades, confirming their extraterrestrial origin. These facts strongly disprove conspiracy claims. Today, humanity stands at the edge of a new lunar era. Multiple nations and private companies are planning missions. Technologies are advancing rapidly, and the dream of returning humans to the moon is closer than ever. The moon is no longer just a symbol of achievement from the past. It is a gateway to the future. Now, let us imagine the next great chapter of lunar exploration. Not just short missions with a small crew, but a sustained human presence on the moon that could last months or even years. If future astronauts travel under NASA's Artemis program, or through international partnerships, their goal will be very different from the Apollo era. Instead of planting flags and returning quickly, they will focus on building infrastructure, testing survival systems, and learning how to live beyond Earth. A future moon base will likely be located near the South Pole, because that region contains areas of near-constant sunlight, which is ideal for solar power and permanently shadowed craters that may hold large amounts of water ice. Energy will be one of the most important needs. Solar panels placed on elevated ridges could provide continuous electricity, while advanced batteries or small nuclear reactors might supply backup power during long lunar nights. Habitats may be partially buried under lunar soil to protect astronauts from harmful cosmic radiation and micrometeorite impacts. Engineers are studying how to use lunar regolith, the fine gray dust covering the surface, as a construction material. With 3D printing technology, robotic systems could build protective walls and landing pads before humans even arrive. Inside these habitats, astronauts would rely on closed-loop life support systems that recycle air and water. Carbon dioxide exhaled by the crew would be removed and oxygen would be regenerated. Water would be filtered and reused multiple times. Food might initially be transported from Earth, but over time, small greenhouse modules could allow astronauts to grow vegetables in controlled environments. Growing plants would not only provide fresh food, but also help recycle carbon dioxide and produce oxygen. Daily life on the moon would look very different from life on Earth. Gravity is only 1/6 as strong, so movements would feel lighter and slower. Long-term exposure to low gravity could weaken muscles and bones, so astronauts would need strict exercise routines to stay healthy. Communication with Earth would involve a slight delay of about 1 to 2 seconds, making conversations feel a bit unusual but still manageable. Medical care would rely heavily on telemedicine and advanced diagnostic equipment. Outside the habitat, astronauts would wear improved spacesuits designed for flexibility and durability. These suits would allow them to walk, bend, and work more easily than the bulky Apollo suits. Exploration teams might travel in pressurized rovers, vehicles large enough to serve as mobile laboratories. These rovers could venture dozens of kilometers from the base, studying geological formations and searching for useful resources. One major objective would be extracting water ice from the lunar soil. If successful, this water could be purified for drinking and split into hydrogen and oxygen for rocket fuel. Producing fuel on the moon would reduce the need to launch everything from Earth, dramatically lowering costs for deep space missions. The moon could become a refueling station for spacecraft heading to Mars. In many ways, the moon is a training ground. Conditions are harsh, but close enough to Earth that emergency return is possible within days. Lessons learned about radiation shielding, resource extraction, and long-duration living will be critical before attempting multi-year missions to Mars. International cooperation will likely play a key role in building a lunar future. Multiple space agencies and private companies are already forming partnerships. Commercial landers may deliver cargo, scientific instruments, and supplies. Private astronauts could one day visit lunar orbit or even the surface, opening a new era of space tourism and commercial development. At the same time, global agreements will be necessary to ensure peaceful use of lunar resources and to prevent conflict. The moon does not belong to any one nation. Its exploration raises important legal and ethical questions. Beyond technology and politics, there is also the human dimension. Living on the moon would test psychological resilience. Astronauts would experience isolation, confined spaces, and a stark environment with no atmosphere, weather, or natural life. Maintaining mental health would be as important as maintaining physical health. Structured schedules, regular communication with family, entertainment systems, and carefully selected crews would all help support well-being. Despite the challenges, the rewards could be extraordinary. A permanent lunar presence would allow continuous scientific observation of the universe from a stable platform with minimal atmospheric interference. Telescopes placed on the far side of the moon could study deep space without radio noise from Earth. Geological studies could reveal more about the early history of our solar system. Technological innovations developed for lunar survival could benefit life on Earth, from improved recycling systems to advanced energy solutions. As we reflect on the entire journey of moon exploration, from the early impact of lunar missions to the historic steps of Apollo astronauts, from decades of robotic mapping to modern missions like Chandrayaan 3 and Chang'e 4, and now to the ambitious goals of Artemis, we see a continuous thread of curiosity and determination. The moon has always been a symbol in human culture, inspiring myths, poetry, and dreams. Today, it is also a destination, a laboratory, and a stepping stone to the wider cosmos. The question is no longer whether humans can reach the moon, because that was answered in 1969. The question now is how we will return, how we will stay, and what we will become as a space-faring civilization. The coming decades may transform the moon from a distant object in the night sky into a second home for humanity, marking the true beginning of our expansion beyond Earth. The story of the moon is not only about rockets, astronauts, or national achievements. It is about human curiosity and the desire to go beyond limits. When early civilizations looked up at the moon, they saw a mystery. They created stories and calendars based on its phases. For thousands of years, it was unreachable. Then in the 20th century, technology transformed imagination into action. The first robotic probes proved the moon could be touched. The Apollo missions proved humans could travel there. And modern programs are proving that we can prepare to stay. One important topic that continues to appear whenever the moon landings are discussed is the idea of conspiracy theories. Some people have claimed that the 1969 landing was staged or filmed on Earth. However, when we examine the facts carefully, the evidence overwhelmingly supports the reality of the missions. During Apollo 11 and the missions that followed, tracking stations not only in the United States, but also in other countries monitored the spacecraft independently. If the landing had been fake, rival nations would have quickly exposed it. The lunar rocks brought back by astronauts have been studied by scientists across the world for decades. Their composition is different from rocks found on Earth and matches what we know about the moon's formation. Special reflectors placed on the lunar surface by astronauts are still used today to measure the exact distance between Earth and the moon by bouncing laser beams off them. Modern high-resolution images taken by lunar orbiters clearly show the remains of landing modules and even the tracks left by astronauts and rovers. When we look at all this evidence together, It forms a consistent and powerful confirmation that humans truly walked on the moon. Conspiracy theories often grow from mistrust or misunderstanding, but science depends on verifiable data, and the data strongly supports the historical record. Moving forward, the moon is becoming more than a symbol of past victory. It is becoming part of future strategy. Governments and private companies now see the moon as a place where science, industry, and exploration can work together. There is serious discussion about mining rare materials, producing fuel from lunar ice, and building research stations that operate year-round. However, with opportunity comes responsibility. The international community must ensure that exploration remains peaceful and sustainable. Agreements such as space treaties emphasize that celestial bodies should be used for the benefit of all humanity. Protecting historically important sites, like the Apollo landing areas, is also being discussed to preserve them as heritage locations. The moon may soon host robotic construction missions that prepare landing pads, power grids, and communication systems before humans arrive. Artificial intelligence will likely guide many of these systems, allowing machines to operate efficiently in the harsh environment. Advances in robotics, materials science, and propulsion will shape how quickly permanent bases become reality. At the same time, education and inspiration play a powerful role. Every major achievement in lunar exploration has inspired generations of students to pursue science and engineering. When people saw Neil Armstrong step onto the surface, many young viewers decided to become scientists or astronauts. In the same way, the Artemis missions and future international landings may motivate a new generation to imagine careers in space exploration. The moon connects science with human emotion. It represents both technical precision and poetic wonder. Looking even further ahead, the moon could become a launch point for deeper missions into the solar system. Because its gravity is weaker than Earth's, launching spacecraft from the moon requires less fuel. If fuel could be produced there using water ice, missions to Mars could become more practical and affordable. The moon may serve as a bridge between Earth and the rest of the solar system. It is close enough for testing, but distant enough to challenge us. Establishing a long-term presence there would prove that humanity can live beyond its home planet. That achievement would mark a turning point in our species' history. We would move from being a civilization confined to one world to one capable of expanding outward. In conclusion, the exploration of the moon is a story of vision, risk, innovation, pause, and renewal. From the early robotic impacts of the Soviet Lunar missions to the historic Apollo 11 landing, from the decades of quiet robotic research to the dramatic successes of Chandrayaan 3 and Chang'e 4, and now to the ambitious goals of the Artemis program, each chapter builds upon the last. Humans stopped going to the moon for a time, but the dream never disappeared. Today, that dream is stronger and more practical than ever before. The moon is no longer just a distant light in the night sky. It is a destination, a laboratory, a training ground, and possibly one day, a second home. The next footprints placed on its surface will not simply repeat history. They will begin a new era. And when future generations look back at this time, they may see it as the moment when humanity truly committed to becoming a spacefaring civilization.